Dr. Larry Sweet, Director of Engineering from the ARM Institute. Larry's got a very extensive resume. I cannot read it here. It's in the program, but spent time at a number of different companies, such as Amazon Robotics, leading initiatives, managing tech transition, and currently wanting to really elicit a conversation here today around, again, we're in the weeds talking about low-level control. We're stepping it up and going a little higher level here. So Larry, the floor is yours. Thank you for coming today.
Oh, thank you. So it's a pleasure to be here. I've worked with Southwest Research, with Paul Evans in particular in the past. Over beers tonight, we can talk about what we learned on that project. I'm delighted to be here. What I'm going to show you today is that ARM has, as one of the 17 manufacturing innovation institutes focused on robotics, has done amazing things in developing new manufacturing capabilities. And it would not have been possible without ROS. So I've had great conversations with Paul and Matt upon this, is that we should really celebrate what's been accomplished so far. The contributions, I think, really form in two ways. One is that teams that are developing the new technology are able to get more directly into developing those applications and not have to worry about how to integrate a bunch of different things together. So basically, they're able to get more out of their available time and the resources that we use to fund those projects. That's number one. Number two is that these teams are intentionally, by our culture, as part of our ecosystem, is to create collaborative teams that involve the end user manufacturer, system integrators, robot companies, other automation technology companies, universities, and startups. And you'll see that reflected in some of the examples I'm going to show you. And these teams tend to inherently be distributed. And so ROS enables them to develop their technology somewhat independently and then bring it together and integrate it together. And I think they'd have a really hard time if they weren't that way. So that's the good news. And sometimes there's a saying, is when you have a good presentation, you talk respectfully about the past, candidly and honestly about the present, and optimistic about the future. So that's what the paradigm I'm going to talk about today. So I'll give you some of the examples of some of these successful projects. But then I'm going to talk about what are some of the challenges that we see now, because our mission at ARM is to get the technology into the hands of U.S. manufacturing. That's why all the manufacturing innovation institutes were created. And so what that means is we want to, the examples you're going to see are for large companies, primarily large aerospace companies, because our primary funding is coming from the Department of Defense. But also we have a charter that we support very actively at Mill 19 in Pittsburgh. We have built up a laboratory that supports small and medium-sized businesses as well that don't have the internal resources and experience, and we want to help them because 85% of manufacturing in the U.S. is done by those companies. So the supply base is really critical. So I'm going to cover that, but then talk about technology transition. As Matt said, I spent the last 15 years at Amazon, previously at Robotic, which is now the key supplier to Walmart, and at Frito-Lay. This was the project that Paul and I worked on in developing. So these were very large companies, but we were involved with the project from end to end. In other words, we were the developers of the technology with our partners, but we also were the system integrators and implementers. And so that involved working with the end users, understanding the real requirements in the manufacturing environment, and understanding the workforce. A lot of our emphasis at ARM is training the workforce that's going to be needed to run all this automation. And so those are all critical factors to making technology transition successful. Some people refer to the range of TRL, MRL, technology readiness level, manufacturing readiness level, levels 4 to 7 is the so-called valley of death. I really don't agree with that because that's where I actually have enjoyed some of the most interesting, technically interesting and satisfying projects to actually go solve those challenges and then actually get them into the hands of real users. And certainly for those big companies, having something that in some cases was able to improve the performance of the whole plant by 30 to 50%. So doing something like that, it's really a blessing to have those opportunities. Now, I've been at ARM for about a year, and during that time, we've done about 20 projects that completed at the end of last year. We did an assessment of those projects. Overall, we've done in the history of ARM about over 100 projects. We now have 450 members. In terms of membership, we are now, number of members, we are the largest of the manufacturing innovation institutes. And our sponsor, Department of Defense, has given us very positive feedback that they like the way we've been handling that and getting our ecosystem members all involved in those projects. So I'll talk about what have you learned about where things have been successful or where the technology transition has not happened yet. What we can learn from those success stories that formulates the strategy of what we're trying to implement right now. So the first thing I'll call out is it was just recently announced an award by the Office of the Secretary of Defense, where they came to us and they appreciate the way we handle the selection, the solicitation of new technology ideas, and how we manage those programs. So they've come to us now twice in the last 18 months to ask us to run competitions for projects that could be implemented within a year. And they've asked us to, they've done this twice. And they've asked us to do this on a multi-institute basis. And so what was announced is the most recent award using our solicitation and award process. And in each case, there were 4 manufacturing institutes that each submitted, solicited around 20 proposals from teams. They each picked their top 5 and submitted them to the Office of Secretary of Defense, where they were the ones who made the final decision, and 3 of the 5 that were selected were the ones that came from ARM. And so I won't go into the details of these projects, but I will come back to this because the things that those teams did were part of the success factors that we want to learn from and implement. So here's a few examples. This is an example of using advanced robotics to do spraying and coating of a variety of these paints, self-coating, other kinds of complex surfaces. Software researchers involved in high speed. Northrop Grumman would be an example of the end user, and Robotics is an integrator. So that's just a typical representation of the kind of teams that we put together for these projects like this. The idea here was innovation is to integrate virtual reality to visualize while the coding is being done, as you're trying to fine-tune the operation to minimize the risk. For example, what you're trying to do here is to have the expert view what's going on and make fine-tuning adjustments to the application that has been programmed through a development model. This is an example. This one is being led by RTX, which is the merger of Raytheon and United Technologies. What's going on here is a lot of interest in all of the aerospace companies in thermoplastic composites, which eliminate the long lead time when you're manufacturing of having to cure the thermosetting type of composite. So the idea here is, can you do welding of these surfaces? You're not making the material, you're taking the material after it's been molded to be certified for aerospace applications. It's not sufficient just to glue them together. You need to weld them together. So the idea here is to develop ultrasonic welding that involves new kinds of welding heads, and also multimodal sensing being developed by Carnegie Mellon up on the upper left. And so the idea is to be able to demonstrate that you can get the quality and the speed out of this application. There's another example. This one is led by again by Ohio State. Basically, you think about this as a robotic blacksmith. So what a blacksmith is doing is they're incrementally heating the material, hammering the material, looking at the shape and going through an iterative process. So you're basically doing a forging, a heat incremental forging process to get the material resiliency and stiffness and properties that you want to have in application. The problem is, think about in a repair situation, the upper left right-hand corner, that's Warner Robins, where it's a depot where they do the repair. Suppose that you find that there's a crack in a landing gear structure, and that part was made 40 years ago. And so if you need a replacement for that, the priority in that environment is to get the airplane back in service as quickly as possible. So the idea is, how could you make a part on site? So the idea here is to robotically go through this process. So the robot is going around going through the scanning process, heating process, hammering process, until you get to the final, that shape. And here's in the lower right-hand corner, you see a demonstration, and that's running at 40 times real speed, but you get a sense of what the operation looks like. This is an example from RPI. This is another example where Southwest Research is involved. Very complex in terms of the number of things that are integrated together. So it's a great example of a ROS-based project. And let's see, here you get a chance. The idea here, this is what is called WAM. It's wire additive manufacturing. So you're basically building up a 3D structure using a welding-like apparatus. You're depositing the weld material to produce the shapes. So those are just some examples of projects that were enabled by ROS. That are capabilities you can't go out on the marketplace and buy commercially. So if we take a step back now and look at the projects that we've had, what are some of the areas that need to be improved? Well, one is that robot integrators are really missing from our ecosystem. We have a few robot integrators, but the majority of the integrator community in the United States are not members of ARM, and they're not actively involved with the projects. So that's a big concern, because they're the critical link in most cases between the projects that are being developed at a laboratory stage and then getting them out into the field. Now, where we have had successes, and I'll point out later, is when a team that was structured from the very beginning. It could be a single company, or it could be a consortium working together. We're going to be involved in the full span of deploying into the field. But it wasn't something where you had a group doing things in a laboratory and then not having the other participants involved. So we need to figure out why the integrators are not involved. And to accomplish that, I met with Roger Christian and his team at Yaskawa, one of our key partners, and his peers at FANUC, because between the two of them, they have two of the largest integrator networks in the United States. So we've had very candid conversations about what we need to do differently to get the integrators involved. One of the big feedbacks we got is that integrators, when they look at the projects, kind of projects that I've shown you this morning, there's too much risk for them to be able to take on the project in its current form. And risk could be that in terms of time, resources, if they're even going to work. So without addressing the risk, they really are reluctant in most cases. So a little more detail here. Just as some examples, if we look at on the left-hand side, I mentioned RPI. They've been working on a number of projects, including that the wire additive was an example, and other projects of blade inspection, where they were using ROS to develop a project. And we had very good input from John Nguyen, who's the head of the department at RPI, and longtime ARM supporter, very, very active. And when I talked to him, and also Michael Graber, who was the PI from Ohio State, they both said, "Larry, I need help. We need help to figure out how do we get integrators interested and willing to work with us," because they put a huge investment into these projects with the hope that they would get into industry, but they have not been successful in doing that. The interesting thing here is the transition that occurred of the projects they've done for GE was it to the GE Research Lab. The RPI is in Troy, New York. It's across the river from GE's corporate lab in Schenectady. And I was a program manager at that lab for 6 years earlier in my career. The problem is that they're great technical people there. They don't have the understanding of the manufacturing environment sufficient to really to accomplish the mission. So having a transition from RPI into the lab at GE it's a form of a transition, but it's not going on a path that gets you moving towards production. Now, over on the right-hand side, I have examples here of Titan Robotics, which is a Pittsburgh-based company. They're using that robot there to do inspection of the fasteners that need to be removed on top of a fighter airplane wing. Might be up to 4,000 fasteners that need to be inspected on a wing. They've done great work that's been in the process of being deployed at Warner Robins Repair Depot in Georgia. And Gray Matter Robotics is another very successful company based in Los Angeles. And they're very advanced in grinding, sanding, polishing. PushCorp, who's represented here, is providing the end effector tooling equipment on the end of that arm. And again, a very, very strong technology transition with both those companies. What was the difference is they don't call themselves integrators, but they are doing the integration themselves. They view themselves as automation companies, so they're taking the full responsibility. The second thing is that when they were created as startups, they drew capabilities out of major universities like Carnegie Mellon, University of Southern California. And so what's happening is they already from the beginning had staff of people that probably were trained in ROS from the beginning and had advanced computer science skills. Now, what they did is they started with ROS, but then to get it into an industrial form, they migrated away from ROS, not because ROS was not capable, but they had to get something that would be accepted into the end-user manufacturing environment. The awards of those that I talked about at the beginning, all three award winners did the same thing. They were companies that were set up from the beginning to accomplish the entire mission, and they had heavy involvement directly with the end users so that you could see a clear path between the remaining work they needed to do in a year to get it into a production environment. So I've already alluded to some of this. So coming into my role as the Director of Engineering at ARM, having had the experience of seeing these projects over the last year, I didn't want to just say, well, what does Larry Sweet think is the right approach? I wanted to draw on our ecosystem to get input. So I've already talked about talking to the automation suppliers. I've had them through Yaskawa and through FANUC. They've introduced me to some of the system integrators who went out and talked to them directly to hear directly from their perspective. Talking to the end users, end user manufacturers, what do they want? For example, the Raytheon talked directly to Collins Aerospace, which is the manufacturers who are actually going to build the parts and build the airplane components. Let's say the cowling that goes around the jet engine. Talked directly to the ARM principal investigators. What does it look like from their perspective? Have gotten very strong encouragement from Harry Pearson, who's at the keynote tomorrow, from the AFRL, Air Force Research Lab, to really focus on the technology, the importance of the technology transition, and very, very strong positive contributions in talking to Paul and Matt here at SWRI from what their ideas are about things that we could do. So what we're doing now is we're looking at, in the upcoming projects for 2024, is defining much more clearly what is it that we are actually expecting in terms of technology maturity. The way ARM has operated up until now is they would have the teams in their proposal say what their TRL or MRL level was going to be, and they were going to self-evaluate. And so they said, this is the goal. We're going to start off, let's say, at a TRL 4, and we're going to take it up to a TRL 6. The problem with that is, in many cases, some of the teams didn't have enough, frankly, experience in understanding what maturity, what the definition really is. And secondly, they would tend to focus on an individual item. And so it may be that there was an item that got advanced from a 4 to a 6, but that's different than saying the system is at that level. So we wanted to have a little bit more clarity and consistency with what is it that we are expecting. And we're trying to do it in a way that's providing flexibility to the teams. We're not being prescriptive about how to do it. We want them to tell us how they're going to do it, but we want to be more direct about defining what is it that we want. So we're defining 3 levels of maturity. The laboratory, which has been basically the majority of the ARM projects so far, quite candidly, they are really basically in a lab environment. I'll show more details of what that means in a minute. The next step is what we call production relevant, and I'll show more detail on that. And then the final step is production representative. When you get to the end of get to the production representative level, you are basically ready for, you're almost ready to go into pilot production. So it's not pilot production yet, but it's close. A lot of the wording that we're putting into our request for proposal at this phase is coming out of directly out of DoD references. I did a lot of research on MRL and TRL definitions. What is let's say the DoD Mantech office, which is a principal conduit of funding to us. How do they define it? But then if you take a look and you strip out some of the DoD-specific language and you look at what is the work content, the work content is stuff that would apply to almost any new manufacturing technology introduction. So if you look in the DoD documents, this would correspond to TRL, MRL 5, 6, and 7. But we made an intentional choice to not actually describe what we're looking for, because there's so many different models that people might have in their heads about what level they're at and what's required. We're focusing on what is it that we want in terms of content. So these are some of the key changes. So the first is that we're asking our proposers to come in and tell us, it's up to you to decide when you submit your proposal, are you aiming for a laboratory environment? Are you aiming for production relevant or production ready? And then underneath that, we're asking, first of all, who's going to actually, when you're doing the demonstration, who's doing the demonstration? Almost every ARM project that I've seen demonstrated was done by the engineers who developed the system themselves. It was not being operated by manufacturing personnel, the kind of operators that are going to be on the factory floor. And quite frankly, with typical scenario, including all the examples I showed you today, there are typically 3 or 4 people with open laptops standing there typing things in there to get the simulation, get the demonstration to work. Now, I'm not saying they were doing anything that was not intellectually or technically honest. They were doing whatever they were doing, but it's not representative of what the operators are going to do. So we were asking that as you get into the production relevant, the majority of the demonstration is being done by manufacturing personnel and technicians. When you get over to the near pilot ready, it's only manufacturing. We want the operating conditions to be representative of the actual operating environment, not a lab environment. And we want the conditions when you're in the pre-production near pilot stage. We want them to be the real operating conditions. The next level down is the maturity of the components, both the hardware and software that are going into the system. So in the laboratory environment, the kind of things that we've been seeing so far is prototype, it's breadboards, prototypes, extensive use of ROS or other tools. And The question is, are those representative of what is going to be used in the production environment? So if a team can say that the end user, let's say if it's a Raytheon, they say these are the requirements that we have in our production world, what's commercially available, what's industry standard. If you can show that that's what's going to be, fine. But also I can tell you, having experience working with companies like Boeing, a company like Boeing will have very, very specific requirements that are specific to what they do and how they do it. And so there may be things that are not typically required on all applications, but those need to be considered. So it's important that the end users are involved in the project early. You don't wait until you think, well, I think I've got to the point I'm near pilot, and then start to have that conversation, because the technical approach that you may take will be different. So that applies to both the hardware and the software. And the other one is we need to understand who is the, Harry Pearson uses the term transition agent. What is the organization that's actually going to take it from the laboratory stage going forward? So in the examples of gray matter and Titan, the ones I showed you earlier, certainly was the case with Walmart and Robotic and Frito-Lay, is we were the transition agent, so we were there from the beginning. If the team is developing something and they're not at that, they're not going to do it themselves. They need to identify who that translation agent might be, and they might, in terms of maybe recruiting integrators and get them on board earlier. So I've made reference to projects. We have issued the request for proposals to ARM members. We did that a few weeks ago, and we will be releasing it publicly to people who are not ARM members next Friday, April 5th. On April 4th, we're having a tech day to invite our members to come in and tell us about their proposals, ask questions, to basically help and coach them along so that they understand the requirements of what we're looking for. We have a special item on the agenda on technology transition because we haven't asked this before, so we want to make sure they understand that. And during the time from when the proposal was issued to now, we've been open to have our telephone lines. I've been getting typically a call or two a day from team members, our members calling in and asking questions of what about this approach or that approach. And we want to just basically help them all be as successful as possible. So this is the schedule. We go through a two-step process where we'll have concept papers submitted by May 1st. And then we will internally score them, rank them, and then we will down select for formal presentations where they will, the down selected group would come in and give presentations to us with the target that at the latest by July 14th is when the project funding actually starts. So what are some of the things that we have ongoing here? In my visits with Fanuc and Yaskawa, I asked them the question, for the teams, clearly there are companies in your integrator network that are doing advanced things today. How is that happening? And so both Fanuc and Yaskawa said they have dedicated teams that help create new functionality, new interfaces to their robot controllers. And I think, Raj, you can verify this. I think the interface to the Yaskawa robot ROS version, I think that your team made contributions to make that happen. So that's just a concrete example. So that, and this is not limited to Fanuc and Yaskawa. It just happens that they are the two biggest active participants with ARM today, and they've offered our support. Well, we're seeing something interesting here, which is companies that start off as integrators. So manufacturing automation systems is an example. In upstate New York, they're a Fanuc integrator. Plus One Robotics is obviously well known to you. Started off as an integrator, and they've changed their business model to offer kits of application specific. So it's the interfaces to the robots, it's the interfaces to 3D scanners, cameras, and effectors, et cetera. So these companies are offering that as a kit that they can give to, or they can sell to integrators to facilitate technology transition. So that we're providing a mechanism to help them get connected to our other members so they can put these projects together. I've already had some preliminary talks with Swiri about ROS Industrial, but I'm really interested whether some new ideas can come out of the conversations we have this week. And the last thing is to go out and help convince integrators to be involved. And what I found is when I've shared presentations like this with them, their eyes say, this is now I'm finally seeing something that can come out of the ARM program that we could be interested in, and they've already expressed interest. So part of it is so we can help recruit integrators to work with you. So with that, I'm ready for questions.
Question for Larry. Maria.
I have a question relating to enhancing your system integrator. I think we also observe the same thing where we came from. So we are from Asia Pacific. I think we also do need to have more vibrant system integrators, but we do see a similar trend whereby the system integrator are not willing to take up the risk, and obviously the business is like making sure projects are profitable after the project, right? And so besides the support that is required, like putting it together from the very start, is there any mechanism that you use as part of the funding to find a more clear pipeline? There's a lot of funding, clear pipeline we might do more.
So ROS-I Asia Pacific asked a question about incentives or plans to improve engagement from the integrator base.
Okay. Very good question. So in the proposal, the document that's already on the street that our members have, that the public will see next Friday, there's a lot more detail. And I intentionally didn't include it here because I didn't want to present something to our non-members. We want to give priority to our members. There's 450 of them. But so you'll see more detail there. There's specific mechanisms with regard to how the funding is handled. So with the teams that I showed you, when we typically put in 50% of the funding, and then the other 50% comes in the form of cost share, which is typically in-kind kind of contributions. That team owns the IP, comes out of that. So that's one of the benefits. The other members of ARM, and this is the way all the institutes work, the other members of ARM have access on an experimental basis to that IP. And then, and if they want to actually commercialize it, then they can license it from the people. So there's a lot of issues that have to be worked through. That's money, decide who owns the IP, et cetera. And so that's a lot of the questions that are coming to me with companies that I listed up there who are doing these kits, is they can make a decision, do they want to offer their kit as something that the prime can buy, can include in their project, and they don't have to share the IP. Or if they want ARM to help pay for adding functionality to their kit to do a new application, then that part of the IP may have to be shared. So there's offline I can be happy to talk to you, but there's a lot of mechanisms that are really serious. It's a big decision for an integrator to decide to want to do it. There's a lot of them, they typically focus on a specific application, like robotics. As an example, they build huge robots that can cover, spray a hole in it. And so they've developed things that they used to be an ARM member, they're not now. And it's not because they're unhappy with it, it's because they wanted to protect their IP.